When we are looking for missing measurements, whether it's a missing side length that like we're looking right there, or it's a missing angle measurement like we're looking right there, you are able to use trigonometric ratios if you're given an angle and a side length or two side lengths in a 90-degree triangle. So let's look at our first problem. Before we get started, we need to firstly identify the angle that's either given to me or the angle I'm looking for, and then we're going to label the sides with an O, an A, and an H. And remember, the H stands for hypotenuse. That's usually the easiest one for us to find because we're familiar with what a hypotenuse is. Opposite is the side that's opposite of that shaded in or that identified angle, the one that's not touching it. And then A stands for adjacent, or the side that's directly adjacent to or next to the angle that we're looking for. At this point, we are able to then decide which trigonometric ratio am I going to use? Am I going to use sine? Am I going to use cosine? Am I going to use tangent? So let's look at the first example together. So this first example, I am given my opposite and I am looking for my adjacent. So then I go down and I say, okay, which trigonometric ratio uses opposite and adjacent? And tangent does. So I know I'm going to use tangent. I like to, and I suggest that you do this as well, is write out the entire, equation like this. So sine of theta is equal to opposite over adjacent. And then you're going to be able to plug in what you know. Do I know what theta is? Yes, I know what that angle measurement is. It's 37. Do I know what the opposite angle is? I do. Or the opposite side, sorry. And then the adjacent side. I don't know what that adjacent side is, or that's what I'm looking for. At this point, it's an algebra problem. You are looking for x. That's something we've been doing, since 6th grade. We're looking for x, getting x by itself. The process or the way that we're going to find x might differ between you and I, but this is the way I'm going to do it. I'm going to multiply both sides by x's because that gets the x out of the denominator. I don't want it there. At this point, I'm trying to get x by itself and it's being multiplied by tangent of 37. So the way that I'm going to get rid of that is divide it by the tangent of 37. Because when I'm dividing it by the tangent of 37, those turn into a 1 where they cross out. And my answer is 3 divided by the tangent of 37. I would appreciate it if you didn't write your answer that way. That's not the most, that would be a very accurate way. But I'm going to look for the rounded or the decimal answer, if you will. And your answer here is 3.98 meters. We will make sure we put meters because it is a unit that's given to us. Now let's look at the second problem here. The second problem, I am given my hypotenuse. I am given my opposite side. So which one am I going to use if I'm given my opposite and given my hypotenuse? And I'm going to use sine. So just like before, I am going to actually write out the whole equation first with the opposite and the hypotenuse and kind of fill it all in because that way I know that I'm not missing anything. Sine of theta, I don't know what theta is. I could either leave it as theta or leave it as an x. Opposite over hypotenuse. At this point, again, we're just at an algebra problem. How do I get x by itself? And this is that tricky part where you're going to want to remember, how do I undo sine? A lot of people think you divide by sine, but we need to remember that sine in itself, taking the sine of something, is an operation. So how do we take the inverse of sine? Well, we take the sine inverse. And when you take the sine inverse from both sides, you will end up with something like this. Now, that is an accurate answer. I think I said this before, I don't want that as your answer. That's a very accurate answer, but it's kind of like leaving your answer as 4/8. I would want it as 1/2, or I want it as a simpler answer. And so we're going to write our decimal answer, plug that all in your calculator, and you get 35.83 degrees if you are rounding it to the nearest hundredth.